Hey everyone, welcome to another deep dive. Ever crack open your laptop or peek inside your desktop and wonder what's really going on in there?
It's pretty amazing when you think about it, all that intricate tech powering our digital lives.
Absolutely. So today, we're going beyond just using computers. We're
Hmm.
diving deep, no pun intended, into the world of computer hardware.
We're going to uncover the magic happening every time you open a program, stream a video, even just move your mouse.
And trust me, you don't need to be a tech whiz to get it. We'll keep it clear, we'll keep it fun.
That's right, because understanding this stuff is for everyone. It's about appreciating the engine that drives our modern world.
Exactly. So where do we even start with something as complex as a computer?
Well, I think to really understand how far we've come, we got to take a trip back in time.
Back to a time before smartphones, before laptops, even before the internet.
Right. It all started, believe it or not, with just wanting to make math easier.
Simpler times.
Yeah.
But I bet those early calculators were a far cry from what we have on our phones today.
Oh, you have no idea. Think gears, cogs, actual physical objects, crunching numbers. But hey, the principle, that was revolutionary.
So who are these mathematical pioneers? Give us some names.
Well, you've got Blaise Pascal back in the 17th century. This guy, he invented a mechanical calculator, and get this, it could add and subtract.
Now that's what I call innovation.
It was huge. Then came along Gottfried Leibniz, another genius. He took it a step further with his stepped reckoner.
Stepped reckoner.
Right.
Sounds intense. What did that bad boy do?
This thing could multiply and divide.
Wow. These early inventions, they really were the building blocks, weren't they?
Absolutely, they paved the way for everything we take for granted today. And it gets even cooler. Picture the 19th century.
Okay, I'm picturing top hats in those old-timey cars.
Right. No electricity, no silicon chips, and yet you have this visionary named Charles Babbage. He dreams up something called the analytical engine.
Analytical engine.
Yeah.
Sounds pretty ambitious for the time.
This thing was light years ahead. Babbage basically imagined a computer that could be programmed. A general-purpose machine, not just for calculations.
Hold on, so he envisioned the modern computer way back then.
He did. He had this idea of using punch cards for input, which, by the way, was totally revolutionary at the time.
So Babbage essentially gave us the blueprint, even if the technology to build it wasn't there yet.
Exactly. He understood the core concept, a machine that could be instructed to carry out different tasks. And that brings us to another critical piece of the puzzle, software.
Software versus hardware. I always mix those up.
It's simpler than you think. Hardware is like the physical stuff, the nuts and bolts. Software is the instructions, the language that tells the hardware what to do.
So it's like, a music box. You've got the box itself, the hardware, and then the cylinder that determines the tune, the software.
Perfect analogy. And the mind who really brought this software idea into focus, that was Alan Turing.
Alan Turing as in the code breaker.
The one and only. He came up with this theoretical machine called the Turing machine, which could theoretically perform any computation imaginable as long as it had the right instructions.
So Turing provided the thinking for Babbage's mechanical dreams.
You got it. But there was still a big question. How do you actually combine this hardware and software in a practical way?
Yeah, how do you go from theory to reality?
That's where our man John von Neumann comes in with his game-changing von Neumann architecture. Now this is where things get really interesting.
Okay, I'm hooked. Lay it on us. What's the von Neumann architecture and why is it such a big deal?
Imagine this, you want your computer to do something, anything, but it can only store the data, not the actual instructions on how to process it.
So it'd be like having a library full of books, but no way to actually read them.
Exactly. You'd need a whole new machine for every single task. Can you imagine? That's where von Neumann comes in. His architecture changed the game.
Okay, so how do you solve that problem?
He proposed this brilliant idea: store both the data and the instructions, the program itself, in the same memory space.
So it's like having the book and the reading glasses all in one place, finally.
Precisely. That way the CTU, the part that actually does the thinking, can access both easily.
Makes sense. And that's how all our computers work today.
Pretty much. It's the foundation of modern computing, this concept of a stored program computer.
But you mentioned this thing called the von Neumann bottleneck. That doesn't sound good.
Yeah, there's a trade-off.
Always a trade-off. What's the catch here?
Well, imagine this. You've got both data and instructions trying to squeeze through the same pathway between the CPU and memory.
So it's like rush hour traffic, everything gets backed up.
Exactly. It creates a bottleneck that can slow things down, especially when you're doing complex tasks.
So how do you fix that? Widen the road?
You could say that.
Hmm?
Computer scientists are always working on clever solutions, like parallel processing, where you handle multiple tasks at once.
Divide and conquer. So even with that bottleneck, the von Neumann architecture has really shaped how we think about computers.
No doubt. It's a testament to how influential a good idea can be.
Absolutely. Speaking of big ideas, let's zoom out a bit, look at the bigger picture.
You mean like the different types of computers out there?
Exactly. It's like exploring a whole ecosystem of machines, each one uniquely adapted to its purpose.
Oh, I like that. You've got everything from the computer in your smartwatch to the ones powering entire stock markets.
So what determines whether a computer needs to be the size of a phone or, say, a refrigerator?
It's all about what you need it to do, right? Take personal computers, for example, your laptops, desktops, even tablets.
The ones we use every day. So what makes them unique hardware-wise?
Well, they're designed for individual use, right? So they need that balance of processing power, storage, and of course they got to be user-friendly.
And even within personal computers, there's a ton of variety, right?
Oh, absolutely. You've got everything from those super slim Ultrabooks to those massive gaming rigs with all the bells and whistles.
So it's all about picking the right tool for the job, whether it's writing a novel or playing the latest video game.
Exactly. Now let's move beyond those personal computers and step into the world of, well, the big leagues.
You mean like those computers that take up entire rooms? The ones you see in movies?
Those are the ones. Mainframe servers, they power everything from financial transactions to scientific research.
So these are the unsung heroes working behind the scenes.
Exactly. Think about all the data generated every single day. Online purchases, social media, even just checking the weather. Those massive computers are handling it all.
It's mind-boggling how much we rely on them without even realizing it.
And then at the very top of the food chain, you've got supercomputers.
Okay, so we're talking next level stuff now, right?
These are the heavy hitters, the ones pushing the boundaries of what's possible. They're used to simulate climate change, model complex molecules for drug discovery. We're talking about tasks that would take a regular computer years, even centuries, to complete.
So they're like time machines, unlocking the secrets of the universe.
In a way, yeah. And they require a massive amount of resources both to build and to maintain.
It's like this constant push and pull in the world of computers, isn't it?
Yeah.
Making things smaller and more powerful for personal use, while also building these massive specialized machines.
That's the beauty of it. It's constantly evolving, driven by innovation and our ever-growing reliance on technology.
Speaking of which, we've talked about the different types of computers, but what about the components themselves? What's actually under the hood?
You want to meet the orchestra, not just hear the music?
Exactly. Let's crack open a computer, so to speak, and see what makes it tick. All right, let's pop the hood on this thing. Where do we even begin when we look inside a computer?
Well, every component has its place, and at the center of it all is the motherboard. Think of it like a city, with roads connecting all the important landmarks.
So it's like the central nervous system, making sure everything can communicate.
Exactly. And speaking of important landmarks, let's talk about the CPU, the central processing unit. That's the brains of the operation.
The CPU, I hear that term all the time. Can you break it down for us? What's it actually doing in there?
It's like the conductor of an orchestra. The CPU fetches instructions from your software, figures out what they mean, and then executes them. Basically, it's calling all the shots.
So every click, every keystroke, it's the CPU making it happen.
You got it. And just like some conductors are quicker than others, CPUs have different processing speeds, measured in gigahertz or gigahertz. The higher the gigahertz, the faster it can process those instructions.
So a faster CPU means a more responsive computer. Got it. But what about memory? How does a computer keep track of everything it needs to do?
The million-dollar question. There are actually two main types of memory: RAM, or random access memory, and storage. Think of RAM like your computer's short-term memory.
Okay, so if the CPU is the conductor, is RAM like the sheet music the orchestra is using?
Perfect analogy. RAM holds the data and instructions that the CPU is actively working on. More RAM means you can run more programs and switch between them smoothly without things slowing down.
So if I'm the type to have a million tabs open at once, I need more RAM.
Exactly. Now, storage, that's your long-term memory. This is where your operating system, your applications, your files, they all live permanently, even when the computer's off.
So if RAM is the sheet music, storage is the entire music library.
Precisely. And there are different types of storage, each with its pros and cons. You've got your hard disk drives, HDDs, which are the older, cheaper option. But nowadays, people are switching to solid-state drives, SSDs, for a simple reason.
Yeah.
Speed.
Yeah, SSDs are supposed to be insanely fast.
Right.
But why is that?
It's all in the design. HDDs have these spinning platters and a moving arm to read data, which slows things down. SSDs have no moving parts, so they're much faster at accessing and storing information.
So that's why my laptop boots up so much faster now. Okay, so we got the brains, the memory, what's left. How do we actually interact with all this tech?
You're talking about input and output devices. They're the bridge between us and the digital world.
Input and output. Break that down for me.
Input devices are how you communicate with the computer. The keyboard, the mouse, even the microphone, they send information into the system.
Okay, so input is like talking to the computer. What about output?
That's how the computer talks back to you. Your monitor, your speakers, even the printer, they take the processed information and present it in a way you understand.
It's like a conversation. We provide input, the computer processes it, and then gives us back the output. Wow, it all seems so much clearer now.
That's the beauty of understanding computer hardware. It's not magic, it's just a beautifully orchestrated system.
And a big thank you to you, our expert, for being such a fantastic guide on this journey through the inner workings of computers.
It was my pleasure. Always happy to share my passion for technology.
We've gone from those early mechanical calculators to the lightning-fast machines we have today. It really makes you appreciate the ingenuity and evolution of it all.
Absolutely. And who knows what amazing advancements are still to come.
That's right. From quantum computing to AI chips, the future of hardware is going to be incredible. So, to everyone listening, keep your curiosity alive and never stop exploring. Thanks for joining us for this deep dive.